In this video, we're going to look at how to use the vertical line test to determine if the graph represents a function. And you can see we have 4 graphs here. They all look pretty different. And we're going to apply the vertical line test to all of them to tell whether they are in fact functions or not. So the vertical line test just says that you can draw vertical lines wherever you want on your graph. And if you run into your graph at more than one point and on any given vertical line, then what you're looking at is not a function. So looking at the top left-hand example, the sideways U-looking thing, if we start drawing vertical lines on this graph, sorry about that, if you start drawing vertical lines, you'll notice that you run into the graph at more than one spot on quite a few of these vertical lines. And what that corresponds to is each of the vertical lines kind of just represents an x value. And at any given x value that I've drawn on there at least, we have 2 y values or 2 output values. And that's the main restriction for whether a relation is a function or not. Every x value or input has to give you only one output or y value. So this example in the top left hand is definitely not a function. So we'll say no, not a function. Now we can do the same thing for the top right example. It's a circle. And again, you can probably already see that if you start drawing vertical lines, or if you run a piece of paper across the graph, that piece of paper or those lines are going to, quite a few of them, run into the circle at 2 different points. So again, that's 2 y values for any one x value on any of those lines I've drawn. And so again, that is not a function. So we'll put no for that as well. Now if you look at the bottom left-hand graph, you can see that if we start drawing vertical lines, no matter where we draw them, we're only running into the graph at one point. And so it has to, of course, be every single possible vertical line, but you can see that there's nowhere that this is going to, that this pattern is going to change. And so the bottom left-hand graph does pass the vertical line test because we only ever have one y value for any given x value. And so that is a function. So we'll put yes for that one. Now finally, let's look at the bottom right-hand graph. And this one's a little bit tricky, so you have to be careful. If you start imagining putting vertical lines, of course you can see the main problem is going to happen right here at the x value of -2 and the x value of +3. You can see there's going to be some kind of issue. But what we have to do is we have to analyze whether we're actually running into the graph at 2 places or not, because it looks like we're running into the graph there and there for x equals 3, and here for x equals -2. But this is where you have to be really careful and be precise in what you're looking at. If you look back at the original graph, we have a hole in the graph on these points right here for this middle section. And so technically that's a spot that's empty. It's a spot that's missing. And so when we do draw a vertical line at, for instance, x equals 3, we are running into the graph at this upper point that I just shaded red, but we're not really running into the graph right here where we have this hole because there's a hole in the graph. It's not actually there. And so here we're really only running into the graph at one point. Or in other words, for this x value of 3, we really only have one y value. And so therefore, if this ever happens, in other words, if you have something stacked up where you have a hole and a solid point, that would still be a function because it does not violate the vertical line test. So this example would be yes. Now, if you had the same example in the bottom right-hand side, but you had a solid dot in both of the slots in question, then of course that would violate the vertical line test, and that would not be a function.